Good evening. Christmas is rapidly approaching, and some of you dads and moms, grandparents, brothers or sisters are looking for a special little gift. That is why tonight we'll have a look at something simple that might cheer up kids or loved ones. And it involves sound, and more specifically, speech. So, if you're ready to build it, take it away, nice sounding electronic lady voice.
Welcome to a new episode on the Technomora channel.
As you can tell, it's a very small setup. You have the speech synthesizer recorder chip here, which is, well, as you can tell for yourselves, a quite simple little device in the sense that it only has a few connections and a hidden chip. We're going to make use of it as it is, but we're going to add a little device that I cooked up, which will allow you to switch it on just by touching a contact. So in this test setup, the contact is represented by this yellow wire here. So if you press it, it speaks. Now, the goal was to create something with certain specifications in mind. So I wanted it to be simple. I mean, in the sense that it's simple to make, and even somebody with, let's say, limited experience in electronics could put it together. Yes, I know you need me. Now, I also wanted it to be safe, in the sense that if we're going to use it, especially where children are concerned, I wanted something which is safe for kids to use. So no high voltage, nothing sticking out or dangerous to swallow up, etc. Okay? The little device that we're going to build can be tucked away safely inside a toy or a doll or whatever you intend to use it for, and whomever is going to use it doesn't even have to throw a switch. It just needs, he or she just needs to touch an electrical contact. I also wanted it cheap, obviously, since, well, mainly Christmas, it can be a little bit heavy on somebody's purse, but I wanted it obviously to be fun as well to make. It's clean, I mean, in the sense that you can build it into something, and there's not even a switch sticking out, so it will be very easy to keep clean. It's easy to build, obviously, and it has a reasonably long running time on batteries. As you can see, the little speech synthesizer setup is powered by only 2 rechargeable AA batteries, which, when they're fully charged, deliver up to, say, 2.7 volts. Now, I've been using these already for a while, and you see the voltage drop to 2.590 millivolts, or 2 volts, 590 millivolts. But it still functions. Now, I'm quite sure some parents will be very happy to know that eventually, of course, the batteries will... Yes, I know you need me. The batteries will run out sooner or later. so you won't be pestered for weeks on end by the little device speaking. Yeah, so I'm sure some parents right now have a grin ear to ear when I say this. It's also small, and it's, for its price and its complexity, it's rather reliable. So there you have it, a little device which can be fun to make. If you're a little bit handy, you can make it in, say, a couple of hours at most, and it's fairly reliable. Obviously it's not some high-end electronics. Now, the way this works actually is there's a little circuit here which I built around an op-amp, and to be more precise, around 1/2 of an op-amp. I'm using an LM358. Now, the goal of the op-amp really is double. It performs, let's say, the task of amplifying a very small signal and transform it in such a way that it can be used to switch on the little speech synthesizer device right here. When I touch the contact, the op-amp transforms the signal and sets in motion, so to speak, the little speech synthesizer. Now, the way my sensor works is really, well, rather simple. We all live in an environment with a lot of AC powered devices, and frankly the air is rather saturated with AC. So what I actually do is, when you touch this little contact here, which functions pretty much like a sort of an antenna, the op-amp picks up any ambient AC, then transforms it and uses it to send an impulse to the speech synthesizer. Alright, I set the sensitivity to a slightly lower. Now, we're measuring at the connection between my amplifier, sensor amplifier, and the speech chip right here. And we're measuring the signal between both. So when the device is inactive, the signal going between them is pretty, well, flat, I would say. There's barely anything we measure. And keep in mind that the oscilloscope is set to 200 millivolts per division. Okay, so now I'm going to touch the contact. Have a look at the signal shape. Okay, I release the contact and it's off. Now, you'll notice that when the speech synthesizer speaks, as it were, you see all sorts of little spikes, sort of like a noise on top of the command signal. Yeah, and that's really, those little spikes are provoked by the little fluctuations of current that are being drawn by the output of the speech synthesizer chip. So when I touch the contact, you can see that the current provokes, that is modulated by the voice really, provokes all sorts of little spikes. Okay, so, well, as you can tell, it's fairly reliable. It all really depends on how you calibrate it. Really, calibration is done by one potentiometer. So Yeah, if you calibrate it a little bit too, let's say, sharply, it will react even to your proximity to the sensor. So in that case, you won't even have to touch it. But that also means if there is any sort of AC spike close to the sensor, that will also fire it off. So the trick really is to calibrate it to such a level that it reacts only when you touch the sensor, but not when you approach it. That's the only really tricky thing about it. All the rest is quite simple. Alright, so this is the schematic. Okay, so you see we're using 1/2 of an LM358 right here with a few passive components around it. So one electrolytic, one 50K trimmer, multi-turn trimmer, and one diode. And around the speech synthesizer tube print, we use one electrolytic, possibly a little switch for recording sound or not, and an electret microphone if you want to record your voice through a microphone. But I loaded the sound you just heard on my speech synthesizer via a audio cable which I connected to my laptop, and I connected it through to the microphone input of the speech synthesizer chip via a 1000 microfarad electrolytic capacitor. That works, of course, just as well as the electret microphone. In fact, I would say that it works better than an electret microphone. As you can tell, the quality is really not high fidelity, and I did my best to improve it to a certain degree so that at least it's understandable even when the battery starts to run low. Yeah, because obviously eventually the batteries will start to drain, and since we power it with only 2 small AA batteries, that might be rather quick, depending on how many times, of course, the speech synthesizer is switched on. And with kids, you can bet that it's going to be switched on a whole lot of number of times. Of course, if you're going to use it for as a help, say for a blind person or an elderly person, or just as a perhaps a reminder for yourself when you switch on some device or other, then the batteries should hold out for quite a long time. The whole circuit uses only a few microamps when it's in standby mode, and so predictably if it's in standby, even a small pair of batteries like those I use, so lithium batteries, it will be able to function for at least a few months. Yeah, anywhere between 2 and 6 months or so in standby. Of course, every time you run it, it consumes about 30 milliamps, but that's only for around 6 seconds, which is pretty close to the maximum amount of time you can record on such a speech synthesizer chip. In fact, if I'm not mistaken, the specification says it's a little bit less than 7 seconds. So you can't say a whole lot on it, but as a toy, say, or just an indicator for something, it's more than sufficient. I'm going to transfer now all the parts you see over there to a little perf board print, PCB let's say, and I'm going to connect it in a more permanent way to the speech synthesizer, and then I'm going to give you perhaps a few more tips and tricks and things you should know before you start building this. So if you're one of those lucky hobbyists who have an oscilloscope, the signal you should see on the play input of the speech synthesizer should look like this when you touch the sensor. Alright, so I built my little sensor on the perf board I showed you a minute ago, and I just transferred from my breadboard the few components that are needed to make the sensor. And in fact, by no means am I an expert in op-amps, alright, but I'll try to explain to you to the best of my abilities how this op-amp sensor really works. In fact, the setup as it is what is called a comparator. But I'll give a little bit more explanation in a few minutes, and don't worry, I'll also add somewhere the finished schematic. Anyway, I transferred all the parts from the breadboard to the perf board you see, and I made it in such a way that it is connected to the speech synthesizer recorder chip you see here. In fact, this is the other side of the print board of the speech synthesizer. Now, what this is really in effect is a little bit of RAM memory. In fact, what is called static RAM, and a analog to digital converter, right? So the AD converter picks up signal from a small microphone, something like this, and this is called an electret microphone. Basically, an electret microphone is nothing more than a sort of variable capacitor. Okay, so two very thin metallic membranes which are separated by air, and since they are so thin, when you speak into the microphone, the two membranes, the two membranes vibrate in respect to each other, which of course, as you all know, is sort of like a capacitor being shook up by noise. Okay, so the two electrodes of the capacitor really are being vibrated in respect to each other, which of course makes the capacitance of the capacitor vary with the sound, and that makes for a quite sensitive little microphone which is called an electret microphone. Now, mind you, an electret microphone does have a polarity, and what you need to figure out when you have a, come on, focus, what you need to figure out when you have an electret, okay, let me give you a close up here. So let me see. There. So on an electret microphone, you have a ground and a positive. Now the ground is connected to the case of the electret microphone, which itself is metal, aluminum in fact. And the way I figure out on this brand, which is really a no-name electret microphone, which is positive, which is negative, is by looking for the traces that run towards the case of the electret microphone. And in this case, you can see 3 very small printed traces on the right side where I hold my finger. And those run to the case of the electret microphone. So that's negative. The other pin is not visibly connected to anything else. So that's the positive. So you really need to take that into account when you connect an electret microphone. Alright, I bought this one in a lot of, I would say, 15 I think, and the whole lot cost me something like $5. So these are really not very expensive. But of course, although they're not expensive, the sound quality of these cheap little electrets are not very good. So don't expect any high quality sound from it. Alternatively, of course, like I briefly said at the beginning of the video, is that you connect the input of your the microphone inputs. You see them there on the left. You see mic negative and mic plus. Alright? So normally you would attach an electret microphone to those two contacts, but you could also connect the output of, say, your laptop or some Walkman or whatever, provided that you keep the output voltage quite low. And by quite low I mean I connected it up to upload the voice that you hear from the speaker to the output of my laptop, and since it's stereo I chose either one of the channels, so it doesn't really matter the left or the right channel, and I set the volume to about 20%. Yeah, so if you listen to the speakers of your laptop, 20% is really very quiet. Okay, so you don't really need that much voltage on the microphone input. Okay, so but in any case I'm going to solder the little electret to it because I believe most of you who are watching this will probably want to use an electret microphone instead of another input device like your laptop or recorder or whatever you want to use for it. Alright, so how does our little device work? Well, it's built around an op-amp, and an op-amp has two inputs, a non-inverting input, which is often symbolized by a plus symbol, and an inverting input, which is symbolized by a minus. And in our case here, it's minus A and plus A, because remember, we're only using one op-amp in the LM358. So there's an A and a B op-amp. Okay, so we're only going to use the A op-amp. Right. Now, the op-amp basically is a device which amplifies any difference in voltage on its two inputs. Okay, so if there is a voltage difference between the non-inverting, which is pin plus A, and the inverting pin, which is minus A, then the op-amp will have the tendency to want to amplify that difference in voltage and to output it on its pin out A. Okay, now our little device, when you see on the pin A plus that it is connected to our little trimmer. Okay, and the little trimmer makes sure that there is always a certain voltage on the non-inverting input, which in our case you'll remember is 700 millivolts positive. That means that any voltage that goes over the 700 millivolts on pin minus A, positive voltage in other words, that difference, say minus A, the inverting input swings to 800 millivolts, that 100 millivolts difference will be amplified and passed through to the output pin of the op-amp. But there's a little twist. If you use the inverting input of the op-amp, any voltage which is applied to this pin will come out of the output pin of the op-amp, but in an inverted voltage. So if you apply plus 100 millivolts to pin minus A, it will come out as minus 100 millivolts on the output, or a bit more really. Actually, it's almost it will swing to the negative rail voltage, which in our case is just ground level or 0 volts. Okay, so the output will have the tendency to go into the reverse direction of the voltage which is being applied to the inverting input. Right? So that's what we're going to exploit to make our little touch sensor switch work. In other words, the trimmer really functions as a sort of a sensitivity level setting. Okay, so with it you can set at which level the inverting input will react to any voltage which is being applied to it. So suppose you touch the contact which is connected to the inverting input. Remember, the touch contact functions as an antenna, and it will pick up any ambient AC in the air. Right? Right. So, as you all know, the AC has a sinusoidal shape, which means that the voltage which you apply here on the inverting input will swing from positive to negative at the rhythm of the AC. And I think I can demonstrate that by showing you on the oscilloscope. The lower trace is a signal to the speech synthesizer. The upper trace is the signal that you receive from the ambient air. So now I'm going to show you what the input contact of the op-amp sees when I touch it. So what it really senses from the ambient air, as it were. So watch the upper trace. Okay, do you see? When I touch the contact, okay, come on, focus. Yeah, Okay, so when I touch the contact, the speech synthesizer starts to speak. Now watch what sort of signal I feed into the contact. Watch the upper trace. You see? You get a signal, an AC signal, not a very clean one, but still. Come on, focus. You see an AC signal on the input, not a very clean one, but still one which moves with the ambient AC. And it's 180 degrees shifted. Okay? So that's what the input of the op-amp sees. Now, what happens is that once you input that AC signal into the op-amp, the output starts to swing in unison with the ambient AC. And when the AC goes into its positive phase on the inverting input A minus, the output of the op-amp goes low. So in effect, it goes to ground. Okay? So once it reaches a certain, let's say, level which is close to ground potential, the play contact on the speech synthesizer, which is positive in effect, suddenly is discharged to ground. Okay? So, and that pulls, of course, the play contact low and starts the speech synthesizer. Now, the only reason why I put a capacitor between those pins here is because I wanted to have a tiny, let's say, a tiny length of time at which the output goes negative. So I wanted to prolong, as it were, a few milliseconds the level, the negative level of the output, so that it's long enough to activate the speech synthesizer. Because if it's only, let's say, 1 millisecond signal or something like that, the speech synthesizer is too insensitive. It won't even notice the voltage dropped. However, if you can prolong the negative drop by, let's say, a few milliseconds, then the play contact of the speech synthesizer will fully discharge into the capacitor, as it were, yeah, and this will drop to ground level and it will start to play. And that's exactly what happens. So if you look at the lower signal trace, okay, so you see the voltage rises from the lowest possible level on the lower trace to a high level and then suddenly drops. Okay, and that drop, that sudden drop, is the output, or rather the play contact of the speech synthesizer suddenly discharging into the capacitor, and that's when it starts to play. Okay, so that's how it works. I'll put a few links down below the video where you can go and read for yourselves on and update a little bit your knowledge on op-amps and etc. Op-amps are really very interesting devices. Of course, nothing let's say prevents you from just using a simple little switch. So an on-off push switch. Okay, so you don't need to build this op-amp setup to use the speech synthesizer. However, you remember we built this because that would allow us to hide everything inside something, a puppet, a toy, a door, a device, okay, and the only thing you would need is a small isolated electrical contact somewhere, just a flat little metallic surface, and that's it. So, which of course makes it much cleaner, much easier to clean, and it's safer for kids, you know. Okay, that's 1, 2, 3, 4. That's 800 millivolts. Okay, so I don't know why my camera is not focusing, but okay. Okay, so that is the shape of the voltage you should see appear, or the pulses I should say, you should see appear on the play contact of the speech synthesizer chip. Alright, so now some of you will say, okay, but I don't have an oscilloscope, so how the heck am I going to calibrate the little device? Well, the trick really is that you set the potentiometer, which you see here, alright? You set the potentiometer in such a way that when you touch the sensor, the speech synthesizer starts. Alright? So if the speech synthesizer reacts the moment you touch it, you're probably somewhere in the right ballpark of setting. Now, if it turns out that it switches on far too often, even when you don't touch the sensor, that means you set the sensitivity a bit too high. So you need to turn the potentiometer back a little. And that's it. So as soon as you see that it only switches on when you touch the sensor contact, then you're good. Now I'm using, like you can see, yeah, and I know I said lithium batteries, but these are nickel-cadmium batteries. But in any case, whether you use nickel-cadmium batteries or lithium-ion batteries, their voltage will always be just a little bit lower than alkaline, that's it. So if you're going to use alkaline batteries, the sound will probably sound a bit louder, and the little device might run a little bit longer, okay, because alkaline batteries do output in general very close to 1.5 volts. It turns out that this chip will perfectly run with, say, a 9-volt battery just as well, but that's typical to this speech synthesizer setup. I'm not sure about other brands, okay, and don't forget it, this is a no-name brand, but it said in the specifications that it could be fed up to 9 volts DC. But it works just as happily on 2.7 volts or even lower. Actually, right now it's being fed 2.6 volts and it still works perfectly. The sound is really not perfect. perfect, okay? So, but I wanted desperately to keep the whole setup as simple as possible. And the cheapest, simplest way I found to make it sound, let's say, acceptable and understandable is by placing a 100 microfarad capacitor between the negative contact for the speaker on the speech synthesizer chipboard and the negative of the speaker, right? And the polarity is, as you can see down there on the schematic. So the negative of the capacitor, the 100 microfarad, is connected to the negative speaker contact on the chipboard, right? Also, I'm using, in this case, an 8 ohm half a watt speaker. You could use a smaller speaker, say something like this perhaps, alright, and this is a 4 ohms 3 watt, but I tried it and the sound is really not that great. In fact, it's rather poor. I even tried what you sometimes find in wish well cards and all that, which is a little electrode speaker like this, very cheap little speaker. But believe me, if you're going to use this for any purpose, the sound is really going to sound very thinny, okay, very quiet, and well, it won't be very understandable. So, well, it's up to you if you want to use this. The only way, though, you're going to make it sound anywhere near loud enough is if you build this into something which can resonate, okay, a piece of wood or a piece of cardboard. But on its own, it's not going to give a lot of sound. Neither is this, alright, so this is not going to work very well. So, in my opinion, the best solution to get enough loud and understandable sound is to use a normal 8 ohm speaker. This is a 2-inch speaker, alright, or possibly even a 2.5-inch speaker. You can buy these quite cheaply on the internet. If you have an old portable radio, you can even use those little speakers. Alright, as long as it's between 4 and 8 ohms impedance. So I'm using a piece of copper tape as sensor. Alright, so you can buy this anywhere on the internet. I happen to have bought this on eBay, but I'm sure you can get it anywhere else. It's adhesive copper tape. Now, basically, any metallic contact, which isn't too large, by the way, will do as sensor surface. Now, remember, the longer this piece of wire is, and the larger this contact is, the more sensitive the sensor will become to ambient AC noise. Alright, so which means that, as you just saw a few seconds ago, the device will just suddenly switch on all by itself. And that has to do, of course, with a momentary AC peak voltages that appear on the AC, because, well, some of you might think AC is just AC, but forget it. It's full of noise and spikes and brownouts, and even if only for a few milliseconds and only for a few volts, sometimes the AC can shoot up and provoke a kind of an RF spike, which is picked up by this sensor. Because remember, this sensor will only work in an environment where there is AC available, like for example in a house. Alright, so as I said, if you attach a small electret microphone to the speech synthesizer chip, then you can also record. And to record, you need to pull the wire which is attached to the record contact on the speech synthesizer chip to ground, okay? And it will sound a sort of a beep when the recording starts, and you need to keep the contact low, so to ground, until you hear two beeps, one after another. So beep beep, and that's when you can unconnect it from ground, and it will, I think, immediately play the recording you did in the electret microphone. So let me show you. This is a test. This is one other test. This is a test. This is one other test. Okay, so the thing is, the electret microphone is not very sensitive, so if you're going to record your voice into the chip, and well, let me let you listen to the recording. This is a test. This is one other test. It's audible for sure, and it's relatively understandable. Of course, my voice and my accent isn't perhaps very understandable to English-speaking people, but in any case, I experienced that the ideal distance to the electret microphone is about, let's say, 2 or 3 inches. So the distance to the electret microphone surface should be about 2 or 3 inches from your mouth to the microphone, and in fact it's best if you speak right next to the microphone, so not right into the microphone but right next to it, and that will improve slightly the quality of the recording. Now, like I said, this is obviously not very sensitive, so what I'm going to do next is hook up my little device to the output of the audio output of my laptop, and I'm going to import another sound. Alright, so I hooked up my laptop to the come on, focus, to the little recording chip, okay, so to the speech synthesizer chip, and in fact I hooked it up parallel with the electret microphone. That doesn't seem to bother it, but what I did do is put a 1000 microfarad capacitor between the output of my laptop and the little speech synthesizer. Okay, so, and I would advise you to do that. It will certainly improve the quality of the sound you import. Leave a comment, give me a thumbs up, and please do subscribe. Right, well, that's it. I think we should leave the last word to my little device. So, my dear, what do you have to say to my audience?
Merry Christmas!
Yes, Merry Christmas, and a Merry Christmas to all of you, and I hope a safe and healthy year. So, until the next video, thanks for watching.